Hello, hello. To just trying to share my. Yeah, we can post it on online or somewhere. Is it presenting on the stream? Can someone check? Sorry. It says it's presenting here, so I'm hoping it is. Yeah. Hello. Hi, everyone. Yeah, thanks for coming along to Svelte London today. I know it's quite far away from wherever you folks are living at because it's in the corner of London, but it's a lovely place. Future House is helpfully hosting us today. Even though no one from their side is here today, we still got access to the venue, which is super awesome. So, yeah, I guess I'll just quickly introduce what Svelte London is. I mean, all of you know what Svelte Society is. Svelte Society is a group of distributed communities all over the world which talk about Svelte. They are officially associated with Svelte as well, so you know that there's no BS going on here. And yeah, so this is the London chapter, which is one of the first ones that opened up. And yeah, so Future House is basically a co-working space. It's like 100 quid a month, and then I think you get 24/7 access to the place. So that's their shout out in case you're interested. I think there's QR codes all over the place if you're living nearby. Yeah. Today's meetup is, of course, sponsored by our own Scott Spence. Scott Spence actually runs most of these out of his own pocket. We don't have any sponsors, so yeah, I think let's just clap for Scott Spence. Yeah, and yeah, so just to get through all of the admin stuff, if you have any emergency evacuations, the toilet is on that side. If you want to leave early or if there's a fire, then I think the fire gate is that door there. So we leave that way. Yeah, of course, Svelte follows this code of conduct and we take it very seriously. We are open to all forms of communities and then all races, all genders, everything, of course. We don't tolerate any form of harassment. If you don't feel comfortable today, you can reach out to one of the self-appointed organizers for the day, which is either me or Praveen there in the red shirt, or Kane as well. And sorry, can you repeat your name? Reach out your name, maybe. Yeah, Viplavi as well. So yeah, these are the organizers you should reach out to if you don't, if you want to chat to us. If you are not sure what the policy is, there's this link here. Yeah, agenda for this evening is two talks, of course. Before getting into that, in case you want to give a talk about Svelte or just show off something cool related to front-end development, then you could reach out to again one of the organizers. And the CFP is always present on our GitHub. You just submit an issue there. So yeah, the two talks for today are building a photo editor in Svelte. So Haydon Lam is starting with that, and then after that we have Andrew Green talking about making a drag and drop website builder in Svelte. And we also have a secret lightning talk by Kundi, who's sitting in the corner there. So that should be really interesting. And so yeah, Hayden, why don't you start? Yeah, I'll disconnect this. And I'll disconnect that as well.
So I've got to connect it now. Great. So does this work? Yeah. Cool. Hello, everyone. Thank you for having me. So yeah, today I'm going to be talking about a little small side project I worked on recently. Building a photo editor. So worked on this in my free time, and I thought it was interesting enough that I thought I'd share a little bit about it with you guys and some of the things that I've learned while building it. I just want to preface as well that there was a lot of learning opportunities for me with this project. I learned a lot of new technologies. So I'm not an expert in any of this, but please ask any questions. I'll try to answer as best I can. Yeah, let's get into it. I think I'll start off with not that. I'll give a quick demo of what it actually is first. So this is the photo editor that I built. Right now we can upload an image. So I'll pick this one, open, and that'll kick off a process of actually decoding that image in the background. And then once that has finished decoding, right, we get the image on the screen. So if I just reset, might as well be a good time to show that we've got the sliders that you would typically find in a photo editor. So I can drag these and that'll adjust the exposure in this case. And the reason it all looks weird right now is because I am storing the operations in local storage so that when you do return, it will keep your changes basically. So if I rotate that again, that works like that. But yeah, after the image is decoded, it actually sends the image data back to JavaScript or Svelte in this case, and it renders it into a HTML canvas, which is what's on the left of the screen right now. So I can drag around, pinch and zoom, reset zoom adjustments, reset adjustments, all that good stuff. But yeah, that's the very basics right now. Obviously, I haven't got much on there, but I can continue to build on this as I go forward. So that's the app. So this is going to be roughly what I'm going to talk about today. You've had the intro, you had a demo. I'm going to talk a little bit about WebAssembly and how I've integrated that into the project, followed by a little bit of performance concerns that I ran into and how I addressed those using web workers, a bit of the UI stuff that I did, and then finally, if everything goes well, we'll actually build a feature together into the app, and hopefully that'll wrap everything up nicely. Right, into WebAssembly. So the first thing that I had to choose with this project was how do I actually handle those raw images? And personally, I've kind of done photo editing before, and I've been around the open source space, tried a bunch of different programs. So I'm familiar with LibRaw, which is this really common library for reading and processing raw digicam images. So that allows me to decode the image and then perform the manipulations on the pixel data. Because of that, that's written in C++, so that sort of chose the stack for this project. And then that leads to Inscripton, which is the sort of toolchain or compiler that brings that C++ code into, compiles into WebAssembly so that I can actually consume it in my application. Also, I'd like, I'm not very experienced in C++ or any of that for that matter. I'm a JavaScript developer. So lots of issues regarding the build, compiling, setting up my development environment. Lots of usage of AI throughout this whole project, as very unfamiliar with this whole stack, question and answers. But yeah, so that's when I thought, surely I can't use LibRaw now. Surely someone's written something similar in Python or Rust, basically, which is how I came across Brawler, right? Same sort of thing as LibRaw, just doing it all written in Rust. And so yeah, that's how I chose my stack. I'm using Rust, and then Wasmpack, which is the equivalent, compiles the Rust into WebAssembly for me to use in my JavaScript app. Overall, I found this stack to be really enjoyable. And really easy to use. Developer experience was great. So that's what I'll get into now. So if we give a really basic demo of how to set sort of that up with Rust, Svelte, and WASM, basically. So, Akash, how does this work?
You could also put it on here, I think.
Yeah. Cool, that works. Yeah, if I head to something I prepared earlier, WASM demo. So to get started, obviously with a Rust project, you have to set up everything, you'll have Rust available in your system, cargo. I'm sure you can find that online, but the basics are you'll start with a file, a lib.rs file in this case. And here I'm importing this module here, this library called WASM bindgen. And what this does is, sort of on a high level, it converts these Rust functions and provides polyfills or whatever, and converts them into something that can be used in JavaScript. And it does that all in compile time. So in this file, I've got this start function, and what WASM bindgen does for this, because I've defined it as a start sort of function, is that will run whenever the WASM module is first initialized. So in here, I'm just logging some stuff to the console and then linking up the loggers. So any log that I make in Rust will actually appear in console log, which is very useful for debugging. And then secondly, I've defined a public function. Public meaning it's just going to be exported, and I can consume it as sort of a module. A simple add function, I'm sure you've seen these before. Give it A and B, and then you'll add them together and return C. So that's the idea. And then to compile that, it's a simple command. So we've got wasm pack build target web. So if we quickly do that with this command, and hopefully it won't take too long. There we go. Perfect. It's going to output your WASM module into this package directory. And in here, it looks very familiar now, all JavaScript stuff. And the reason I think I really like WASM pack is because it almost assumes you're going to publish it as an NPM library, and that's definitely something that you can do. So we've got package.json, it's all set up, and then this raw processor.js file is the main entry point that we want to load into our Svelte app. And what's really nice is that it provides a TypeScript declaration file. So all of those functions that I exported from Rust, so that add function, we have, it's declared right here with A as a number, B as a number, which returns a number, which is brilliant, right? So with this, we can simply import it into our Svelte app like this. So I'm firstly importing an init module, which that fetches the WASM module and then runs all this initialization stuff. And then secondly, I'm importing this add function. Some basic Svelte here. I'm using Svelte 5, so I've got the state runes to initialize the state, binding it to 2 inputs, and then the button click will run that function. So before, I was going to jump into the demo, but what I really wanted to show is that this doesn't actually work because package is outside of the source directory, and Vite doesn't like that. So I mentioned there's a couple of options you can do here, which is obviously publish this as an NPM library, which you can then install again. But what I prefer to do, and what I found to be the more seamless setup, is just passing in a CLI flag, the out directory, which if I run the build command again, it's going to output the WASM files inside of source, inside of lib. So it's within my source code. And so if I just come back here, from there, I can use the import it like that. And it's not happy, I'll probably just restart the language server. Still not happy. Lib, raw processor. Classic. It breaks when I do a demo. We'll try and run it again. We'll just run the app and see what happens. So if I come here, and then that will hopefully refresh on its own. Yeah, that should work.
What does Svelte config look like?
Svelte config, it's just typical standard thing. Pre-process, and then I'm using static adapter in this case, so nothing fancy going on there.
Does it need something to do with that?
It should all work. Oh, right, 404 is because it's on this edit page. There we go. Damn it. Why is it not working? Right, we'll try and delete that and then build it again. Or maybe okay, so it should be there. Let's try and run that again. There we go. All right, perfect. So yeah, like I mentioned earlier, we had that start function and it runs it automatically. And then we have the two numbers which we can try and add together. Oh, cool. 4 plus 4 is 8. Perfect. So yeah, that's my quick little demo on the Rust and WASM setup. Here's the little summary. Hopefully I've made it look easy and inspired you guys to get sort of involved and try it out. But yeah, you start off with your librs file, you run the command, and then out goes your output in the package directory or wherever you want to output that, and then you can consume it in your Svelte or whatever app that you want. This is the part now where we've got a little bit of an understanding of the WASM setup. So I wanted to quickly show, if I have to now undo all my changes to change the branch. Just undo. Cool, so I wanted to talk about the image processor. So what you saw earlier in the demo is we first upload the image. So I wanted to run you guys through sort of what I came up with how all of this works from, let's refresh. Nope, we gotta build the module. And this will take a little longer because it's doing the whole build. All right. Come back here. So yeah, how does all of this work, right? I upload the image, and then that gets sent into WASM somehow, which decodes it, and then, you know, we get the data back, and we can pull all the sliders. How does that actually work? Right, all of this. So what I have in my WebAssembly code is I've defined a class, image processor class, to which I can create a new instance of by passing it an image. What that'll do is within that constructor, it will decode the image for me and then assign a couple of variables to that class instance. So in this case, it will be a decoded image. There will be some metadata and an array of operations. Those operations being your sort of exposure and your contrast and all that stuff. Once I have that class, I'll store it in memory within my JavaScript, whether that's like in state or just your basic, just have it somewhere stored within my application. And then I can interact with that class instance to perform those operations. So after the image is decoded, I can send these functions to the image processor class, set exposure 1.5, set contrast, and that'll store it in that array of operations. And then after that, I can request another function, apply operations. And what they'll do is it will take the decoded image that we got originally. It'll run all those operations through it, exposure, contrast. And then out the other end is the edited image, which I can then bring into my, my canvas element and render the image. And that sort of happens every single time. So here we've got the class instance. Every time I drag this slider, it will push that function, and then I'll call apply and get the image out the other side. And that's all defined in here, image processor. So this is my struct, which sort of just compiles into a JavaScript class. And then here in the constructor, given the image data, I'll decode it and then store that data into the class. And yeah, we've got apply operations, which takes a hash map of all those operations deduped so that we don't run over the same operation twice. And yeah, it will apply those and then give me the edit image as an RGB. So that's sort of how it works. And then below we've got set exposure, set rotation, all that stuff. And going forward, I'll just simply add additional functions to this, which we'll actually go over later. And I'll skip through this. Maybe we can talk about it if we have time later. I want to talk about dispatching events. So I'm sure you remember whenever we upload an image, it runs a decoding process on that image, and then we get updates on the progress of that decoding process. And the way I achieve this, and it's actually an interesting WASM feature, is that the WASM code actually has access to web APIs. So within WASM, I have access to window. I have access to, in this case, what I'm using is dispatch event. And it's very interesting because sort of more larger WebAssembly applications, like I think Figma or something like that, they actually make all of their sort of UI code and UI changes from inside WASM. Because what they'll do is they'll do like document query selector canvas from within their WASM code and then pass data directly to it. And that actually is more efficient because you don't have to pass the data through this sort of bridge into JavaScript and then manipulate it from within JavaScript. It all happens within that low-level code. But yeah, so that's an interesting feature which I'll show you here, which is essentially, I have this module for dispatching events. And yeah, so extern C is essentially referring to window. That's how the WASM bindgen does it, I think. I'm not entirely sure, but that's referring to the window, and then I can declare sort of this dispatch event, which is reference to window.dispatch event. And by defining it here, I have access to use it within my Rust code, which I've kind of packaged into this function here, dispatch event worker. And you'll see throughout my decode function, I'm calling that and dispatching events. So obtaining raw, decoding metadata, decoding raw data, developing raw, and then finally complete. And then if I go to the image upload component, essentially under the hood, what this function is doing is it's listening to those events and then pushing those events to an array, which I have defined here. It's just a local state within the component. And below where I do the UI is, if that event is in the array, I'll render a check mark. If it's not, then it's essentially loading and it's still sort of being processed. So yeah, that's sort of how that works. Right, next I'll talk a little bit about performance and web workers. So when you're processing images, it's a lot of data, right? One of those raw images that I have is, say, 30 megabytes. It could go up to 50 or even higher. And so running operations on every single pixel is very intensive. And that's something that I ran into. It would essentially freeze the entire app while it was decoding, and I'll try to demonstrate that for you now. That should work. If I come to the app, cool. So in this branch, you'll see I've got a timer which updates every single second. So as long as we keep an eye on that, we'll know that the UI is still responsive. And right now, what it's set up to do is run the decoding function directly within JavaScript code. So no workers, no nothing yet. We'll get to that. So if I upload image, and I'll pick this one again, keep an eye on that time. It will actually freeze while it's decoding. No updates. I can't interact with the page. I can't highlight anything. And then maybe 10 seconds later, it will finish decoding. Yeah, and then it becomes responsive again. So this is something we definitely don't want with our application. And the solution to this is using web workers. And web workers will allow me to push this process, this function, this operation into a separate process, let that happen in the background. And once it's finished, I can get that data back out of the worker. So what that looks like within my code is here. Within the upload, this is calling that image processor class directly. But what I want to do is call this class from within the worker. So if I comment that out and then use this raw processor worker.decode, and then inside of there, this is my worker file. And I won't go into too much, but I'm using comlink for handling my workers. Very, very good library. Essentially, typically with workers, you have to handle the communication through events. So, you'd do add event listener to get the data and then sending it back. You'd have to post message, and you have to do this whole back and forth. Comlink, if you're interested, you should look into it. It does it very easily. I just define functions, which I can call from Svelte, and the return value of that function is just sent straight back into Svelte as well. So very, very good. Makes it very easy to use workers. But yeah, the decode function here is calling the image processor class from within the worker. So if I now save that, we should see, again, keep an eye on the timer. If I now open this image, it's responsive. So the UI is constantly being updated every single second while that's being run in the background. And once it's finished, it should inform my Svelte application that it's finished, and then we can update the state. So this is exactly what I needed to address those problems. And like I said, if you have sort of these issues and you need to use web workers, I definitely recommend comlink as a way of handling that. Cool. If I undo that, and then we'll go back to main really quick. Right, UI, nearly there. So for my UI, for those sliders especially, I needed something that was, I could bring my own styles, so I can apply my own design language to it. I wanted something that's accessible, because a lot of photo editing software, people use the mouse to do the macro adjustments, right? Get it all the way up to really bright. But then they'll want to use the keyboard to hit the keys, hit the left and right keys to make those finer adjustments. So it has to be accessible. It has to have those features built in. And lastly, it has to be flexible, because there's a few features that I mentioned here that I want to integrate and override, which is double click to reset and a sticky base value, which I'll possibly show you in a bit. In React land, I would use something like Radix. I've used that at work. Used it personally, it's fantastic. Comes with all of this out of the box, and I can bring my own style. So, when I use it at work, we have our own design system. It's fantastic. And in Svelte land, there is, as the title suggests, I'm using Melt UI, which does all of this as well. It comes with all of the accessibility thought out for you, and you can bring your own styles. Yeah, there we go. It ticks all my boxes to achieve the slider that's I've got in my app. So a quick little bit of code demo for how I achieved all this. This is the before the slider. So I've got a simple span, and then this code here is sort of the Melt UI stuff. We can it uses the use directive with actions. So I pass in the pre-built range component, which handles all the functionality for me. And then I've got a class of range, which applies the styling, the background color and all that stuff. But yeah, like you see, the slider, the highlighted region is not what I want. I want the left of the highlighted region to be at some sort of base value, some midpoint. So what I can do is simply apply style as I would with any element. There's no need to hack around it. The component library, I can bring my own styles. In this case, I apply the style, and then that calls a function which basically sets a left style on it. It's just calculating the distance from the base, all that stuff. But yeah, it applies a left and a right style, which allows me to customize the region that's highlighted. Next is the double tap to reset. So typically, if I want to reset it back to the default value, I can double click anywhere within the field, and it will transition it back to the default value. And similarly, I can override the functionality here by what I've got is the double tap action, which simply attaches a couple of event listeners, click event listeners. I'm just tracking the interval time with the last click and then double tap time. And then, yeah, applying it to the slider using an action, right? Use double tap, I request a slider transition, and then we set the store value back to the base value. So that's how that works, very, very simple, which is, why I love to, Melt UI for this sort of stuff. One problem I ran into was, in this case, I can use Melt UI perfectly fine with native HTML elements. In this case, a button, pass use :melt, and then I pass in the component builder. But I'm sure a lot of you have your custom implementation, your custom Svelte component with your custom styles, right? And what we get is this: we can't use a use directive on a custom component. So the workaround for this that I found, and perhaps you'll find this useful as well, is directly from the Melt UI docs, is it tells you how the preprocessor actually handles the directive, and actually takes that component builder and it spreads it into the component as props, followed by simply applying that action to it. So what we can do is, to my custom component, I can expose a custom prop, which I've chosen to be use_melt. And then, yeah, if I pass in something into here, I'll do the exact same thing that Melt UI would do under the hood, and I would spread that component as props, and then pass in the action. And using this really simple workaround, I can, use Melt UI with custom components. Cool. We've reached the point now where I'll do hopefully a demo that doesn't fail on me. So let's implement a feature. What I'll do is we'll start with the image processor. So what I'm going to try and implement now, which hopefully I've tested before, is implement a saturation slider. So we'll start off within the Rust module, within the image processor, and I've got a function here, set saturation. What this is doing is it's pushing something to the operations array of type saturation. And then if I just highlight all this, cool, not that. Right, and then here I'm taking the image, I'm getting a mutable reference so that I don't have to clone it. That's more efficient because as long as I can directly modify the image pixels, then yeah, I don't have to clone it and then do all this faffing about with. Now I have two 30 megabyte files in memory. And then for each pixel, this is just an algorithm, a little formula for adjusting the saturation level based on this value here, which is something between 0 and 2, for example. I need to add this saturation type. Cool. So now that I have this function, I need to put it back into the apply operations function. Otherwise, it's not going to do anything. So that'll be this section here. And yeah, what that's doing is it's grabbing the saturation operation and applying it to that mutable image. That should be it, and I'll build the WASM module from here. And if everything works, then we should hopefully see that set saturation function available in our TypeScript module. Give it some time. Right, while we wait for that, we need to next go into the worker because that's where we handle the image processing. So if we go to raw processor here, when we decode, we want to, of course, handle any existing operations that we had. So if saturation doesn't equal to 1, then image processor dot set. Okay, cool. It's finished building. So TypeScript has picked up. We have this function now. So set saturation and operations dot saturation. That's not happy. Just a TypeScript thing. So we add saturation. We add it here as well with a comma. Cool. And then finally, in apply operations from Svelte side, we also want to apply that there. Right, let's speed into it. The next thing we need to do now is contrast. We'll copy and paste this component. Saturation. So this is the slider component. And what I can do is I can bind it to that saturation value. And for saturation, the base is 1, minimum is 0. And max, let's make it 2. And then we give it a label. Then quickly, I think I have a sidebar component. No. And then let's just render that here. Cool. And yeah, this will be it, hopefully. So yeah, we've got a saturation slider now, all hooked up. And it should work, hopefully. If I drag to 0, it should make it grayscale. Yep. That's it, cool. I'm in for time. Yeah, thank you. Are we good on time?
Any questions for Haydon?
Yeah.
Yes.
How do you find Rust and JavaScript? It's two totally different mindsets.
How do you find Rust and JavaScript? I'm just repeating for the audience.
Yeah, so I used a lot of AI to help out. Obviously, I think it's quite nice for my use case anyway, and the fact that the WASM compiler maps similar concepts for you. So like a struct in Rust would map to a class. So I would sort of work around that, and then functions are functions, right? There's obviously a couple of things in Rust which you need to get your head around with handling memory and all that stuff. I couldn't go into that. But for the most part, yeah, it was enjoyable with a little helping hand.
Thank you.
No other questions?
Any other questions? Yeah. Go ahead, Sai.
Actually, a couple of questions.
You
so
mind coming here then? Like, you could just speak into the mic if you wanted to. Or
So, are you focusing on the WASM part of the library, or are you building a photo editor using this person? What's your focus?
yeah, I mean, you can.
So
repeat
the question
if you want.
is, am I focusing on the WASM part of it or
Or the image parser or the editor?
or the editor? It would be both. I mean, if I'm honest, this is just a fun project for me. I'm not really expecting anything out of it. I think if I was to build this further, I would have to focus on WASM and on the editor side as well to implement features. So I can really say one or the other. It's a bit of both.
And I'm actually interested in the WASM stuff because I have a image compression module in my product. Currently, I'm using server-side optimization for that, which I would ideally like to shift all those operations into client-side. So, can you recommend any WASM library that's already present for image optimization, or should I wait for yours to become?
I wouldn't rely on mine. Like I said, probably not going to make this anything public, but yeah. So, like I mentioned, I use Roller, and then if it's C++, I would recommend LibRaw, but again, I'm not sure if those handle optimizations per se. So yeah, I don't think I could help you answer that question.
Okay, thank you.
Cool, I think that's it. Thank you very much.
Cool. Thanks, Haydon. So, could you keep that here for a minute because you're currently streaming audio. So, yeah, Andrew Green is coming up next, talking about building a drag and droppable website using Svelte. So, yeah, let's go. Have you already joined the stream? Yep, you are visible already.
Yep. And
you need to start presenting.
I need to start presenting, I see. Share screen. Share screen. I want to share the entire screen.
Yeah, if you click here, then
That's it. That's that.
perfect.
Down like that. Come up like that. And fingers crossed we're there. Oh, wow. Hello. Yeah, shall I just start?
Yeah, you can.
Yeah, okay. Oh my God, wow. It's kind of amazing to be here. Thank you so much. For those of you I haven't already spoken to, my name's Andrew Green and I work for a new event management software as a service startup called Tenzen. We're a little bit like Cvent, if you've ever encountered them, but considerably less complicated, and a little tiny bit like Eventbrite, who I'm sure you've encountered before, but rather more complicated. And we like to think that depending upon what you're doing, we're probably cheaper than both of them. So our product is really there if you're running something like a business conference and you need to market your event to potential attendees, handle registrations, take payment for tickets, check people in when they arrive, that kind of thing. So it includes, this is fab, it includes a registration form builder, email marketing tools, an agenda builder, a badge designer, there's a check-in app, a virtual event environment. There's lots of stuff in there. But the thing that I'm talking about today is specifically our event website builder. But first, just a little bit of history by way of context. About 10 years ago, my colleague Ian was running events for the automotive sector, and I helped out with this, not that I know the first thing about cars, but I helped out with this by building a registration and check-in system for him. And by about 2019, we decided to wind that down and instead focus on trying to build out that software as a product. And it's taken us the best part of the 4 years since then to be able to bring it to market, and I still have a roadmap as long as my arm. But for myself, it's very much true to say that the microphone is dipping. There we go. Let's try that. I started building websites all the way back in 1995. The very first one that I worked on was the first website for the University of Kent Students' Union, which sounds like it might be a flex until you actually find it on archive.org. But it's true to say that I'm an HTML kid. I'm absolutely not a JavaScript kid. So what I was used to with building websites with a little sort of smattering of jQuery in there for showbiz really wasn't going to cut it for what we had in mind here. We needed something that was much more app-like, something that was much more modern, something that was much more reactive. And so obviously we looked at React. And I very, very quickly found that I do not understand React. I can't get my head around it. I think it's mostly because of how JavaScript forward it is, to be honest. You have to write functions that return fragments of HTML rather than writing HTML that calls JavaScript functions. Maybe that's a rationalization for it. It's just that I'm dumb. But either way, that was a little bit of a roadblock for us. So Svelte to the rescue. We're using Svelte for pretty much all of our UI code. I basically found that I could just about wrap my head around that. Not like many of the people in this room can. It's kind of preposterous that I'm up here talking to you, but there we go. Enough to at least get cracking on the on the insane task that we'd set ourselves. So yeah, what my code lacks in quality, it gains in volume. The last count the platform had somewhere north of 760 components in it. And we're also using Svelte for our virtual event environment and the browser-based virtual studio and our check-in app and various other things. So there's a lot there. The day will come that I have to convert it all to Svelte 5, but friends, that day is not today. So that's obviously a large part of the story here, but there is the back end, there is the other half of the story. And when I said that I'm an HTML kid, that's a little bit of a lie, because really, fundamentally, deep down in my soul, I'm actually a Perl kid. I'm a believer in using the right tool for the job, but sometimes the right tool for the job is the one that you know how to be productive in, especially if you've set yourself a certain amount of time pressure to get things done. So our internal API, for good or for evil, is built in Perl, and that uses I hesitate to call it a framework because that's a little bit grand, but a sort of app framework that I've been working on for the best part of 15 years via client websites. And that brings me at last to how our event website builder is actually put together. So we have the Svelte UI for making changes to pages and editing the content that outputs a JSON representation of the page, just the sequence of content on there and the various properties that it has. That's sent to our internal API, which obviously stores it in the database, part of which is then a renderer to output HTML, and that is the event website that attendees or potential attendees go and look at. So it's effectively just a really simple headless CMS. Obviously, we could have used Svelte for rendering the event website through, well, now SvelteKit, it would have been Sapper at the time. But I knew that I would want to use the same renderer for things like rendering HTML emails. And so it sort of made sense to do it this way, besides which I was quite confident with the templating system that I'd already built in Perl.
Can I just ask a little question? Is that the JSON and the internal part?
Yes. No. Sorry. The JSON is done in Svelte and sent to the internal API, which then just stores it and then sends that on to the renderer effectively. All right. So that basically is time now to give you a little demo of it. So here we have got the dev version of our platform. Okay, that has come up good. I've set up an account for the Svelte Society. And an event in the system for Meetup tonight. I'm in the site builder part of it. There's obviously other things down here that we could do, like setting the agenda and marketing emails and whatnot. And I'm editing the home page. You can have as many pages as you like. We don't restrict you. And obviously it takes care of the navigation and things like that in there. So something that's immediately clear is that we've split the page into two. We've got a preview of the entire page down here on the left-hand side, and then this panel over on the right for making changes to it. And we've got this sequence of, frustratingly in the context of what we're talking about, we've called these things components, these sections of the page. So bear with me on that, because I know that's probably a little bit awkward given we're talking about Svelte. But anyway, if I click a component, it opens up in the panel over on the right-hand side here. So if I wanted to change that background image to something else I've already uploaded, I can just choose the background image. I can change that overlay to a color. Let's change that to the purple, maybe make it slightly less opaque, and maybe just a fraction smaller as well. So just bring that in and then save that. And that's our page edited. So it's really, really simple. And any edits that you make are reflected immediately in the preview over here. If I want to change the sequence of content on the page, let's say I wanted to move this up above that video, I just basically drag it. We get this little indicator line to indicate where you're going to be able to drop it. If I move that up a little bit further, it should scroll, and then I can drop it there if I want to, but I don't want to. I want to move it here. And then that just moves that there, opens it up for editing it, or I can just cancel that and it's just moved. So really, really simple. But obviously a thing that you will have noticed is that we're not trying to do any kind of direct editing in the preview. It's not like Wix or Squarespace or things like that. And there's a whole bunch of reasons for that. The first one is that that kind of thing looks incredibly hard and intimidating, and I don't fancy trying to do it. Another one is that we're not actually trying to compete with Wix and Squarespace. This isn't a sort of general purpose, fully fledged site builder. Our target audience are event planners who have other things that they want to be doing, and really they want to just be able to produce something quick that's credible and hopefully reasonably well designed, but that doesn't take an awful lot of effort. They're not sort of putting a lot of time into getting this just so. Another reason is that personally I don't massively love that way of doing things. I find with them that the preview isn't massively faithful to what you actually see at the other end, and because you're obscuring parts of the page with your various controls and the panel for overlaying, sort of an overlay panel to edit things, it ends up being a little bit difficult to really orient yourself and see where you are. I kind of think this is actually slightly easier. And the final one is that one of our design objectives here was to try and have as consistent a UI across the whole piece as we possibly could. So the idea is that once you've gotten used to editing a web page, you already know how to edit an email, and you already know how to edit a badge and things like that. So we've tried to keep it very, very much the same sort of UI across the whole thing. So the preview is basically an iframe that's got the actual rendered content of the page in it. But we've rendered the iframes in a little container, and then the iframe is oversized so that it's about the size of your actual screen, if it's a desktop screen. And then we apply a CSS transform to it so that it squishes itself back down to the size of the preview. So that's why this is basically roughly half size. But that works really well. Everything, you know, looks pretty good, and you can get a good sense of where you are with it, even at half size. Oh yeah, that's it. The other little Brucey bonus of this is that we've got this little control, whoops, down the bottom for being able to toggle between the desktop view, a tablet view, and a mobile view of the page. And literally all that's doing is constraining the width of the iframe. That's all we have to do. The browser takes care of everything else, and the responsive CSS that's in there just handles redrawing everything. We don't need to really sort of fuss with that. All right, so what I want to quickly do is add a couple of new components just to show you those. So if I click to add a new component, we get this little catalog of chips down the side. And these are obviously also very much focused on this being an event website builder rather than a general purpose site builder. So we've got stuff like the full agenda, an exhibitors list, and so on. What I want to do is add a map to the page. And we've already plugged in the venue details into the system. So it's just come up with a map that's already sort of put in for that. I can just edit this here. This little editor that's just a very simple content editor is Quill. There is now, as of about a month ago, Quill 2, which I'm going to try and integrate into this. But I haven't done that yet. It's one of the many things on the roadmap. But integrating Quill was actually really straightforward with Svelte. It gave us no trouble at all. It's nice and simple. It allowed us to extend it with a couple of additional buttons for things like button links within there. And we're moved a lot of the more complicated stuff out onto separate controls here rather than trying to put it within the editor itself. So let me just move that text down so that it's in the middle. I want to make that, whoops, text maybe large, and let's change the background color. So I'm going to set that to that purple, white, white, and let's maybe change that from Google Maps to Map Box. I'm going to change the blend mode that uses, and then change the balance of it, and all of that happens really instantly. And there's our map. Thank you very much. Let's also add a sponsors grid. So I'm going to add that right down to the bottom of the page. So as you can see, I'm dragging over the footer here, and that's put the little marker at the bottom. We'll come back to that. So we've put into the system a very simple event-centric CRM, because in for a penny. So I've already added a few companies to that we can use as sponsors here. So let's add a Tenzen, and that just builds in their logo, or our logo. Starling, because I know Haydon works with Starling. Apple. CrowdStrike is there, but I didn't put a logo there for them, so tough. Vesuvio Pizza, who I believe are the pizza people around the corner, but I don't know whether we're actually using them, and Vercel. So there's a little array of logos, and I can make sure that those link to the sponsor websites. And if I wanted to, I could also change the background color. So let's give that an orange background color, which looks bloody awful because we've got these little white boxes for the logos. So let's recolor those and set those to white, and then we've got that lovely monochrome look. And maybe let's also set some animation on there. Save, and there's our sponsor bit down the bottom, which is nice and straightforward. So one of the things I forgot to mention is we've got this sequence of components on the page, but the masthead and the footer aren't among them. Those can't be edited here. We've got this, we've got a little branding section in event setup where you do things like set your fonts, set your colors, and choose a design theme for it. And that determines things like whether or not buttons have rounded edges, whether speaker photos are in circles or in squares. Can't make your speaker photos look like less of a reprobate, but there we are. The style of these kind of quote cards and things like that. So we offload a fair amount of the design decisions that you might make onto the theme, and some themes are more opinionated than others. For example, this one has that sort of circular design on the overlay in something like a hero. Other ones are just much more straightforward, just a straight line down there. That means that most of these components are relatively simple in terms of what you see when you go to edit them. So if I'm editing this picture here, I don't have stuff to do with whether or not it's in like, give that a background tint perhaps, you know, whether it's got rounded edges or stuff like that. It's pretty straightforward. I can make it slightly taller, make it shorter, and so on. Okay, so there's our page. If I go onto the staging site, here's the actual website as rendered from what we had there, and as you can see, it is identical to the preview that we just had. So that's that. Okay. Well, thank you very much. All right, let's have a look at some code snippets. So I mentioned that it's a JSON representation of the page. Here's a very simple array of components. Each one has an ID, which is going to be really important later. Tells you the kind of component that it is, and then sets some properties that are specific to that component. So for a video, we know that it's from YouTube, and we know the video ID from it. That's pulled out of a URL that you can paste into Svelte, and then there's some display properties for that. Here's the image of Scott, who's not here to defend himself. And here it's just pulling out the image from the little library. When we upload an image, or when you upload an image, we pass it through the Google Vision API, which tells us, pulls out the focal point for it and gives us a dominant color, and that can be quite useful for things. So that's pretty straightforward. And when you load up a page in the editor, in the site builder, it acquires that JSON representation back from the internal API, from the database. And we also, along with that payload, provide the rendered HTML for the page that we're then going to stick onto into the iframe. But we call it in a sort of preview mode, which essentially just wraps each component in a little bit of extra HTML to declare things as draggable, to give us the ID of the component in a data attribute, and to just have this little tiny extra bit of HTML in there that represents the drop target. And that's the thing that we're going to animate when you drag something over it. And we offload as much as we can to CSS variables, because those become really straightforward and easy to update, and then the browser just takes care of anything awkward to do with that. So we'll look at that in a little bit. So it's just really simple. On the page itself, in the Svelte app, we just have an iframe that initially is just about blank. We're going to inject that HTML content into it using src-doc in just a second. We bind the iframe to a variable because that's going to be handy too, and we make sure that the iframe is handled as same origin, and also allow scripts so that basically just so that the maps can render and the animations can render and stuff like that, because those are done JavaScript in the actual page itself. So having got the HTML out of the API, we use box src. Well, box is the variable that we bound to the iframe, so we update src-doc on the iframe, and then we're going to run a function to basically add a load of event listeners, fundamentally. We're also going to bind the content document to a store, because that's quite useful later on as well. So add an event listener for click, and then add a bunch of event listeners for drag and drop. There are a load of libraries for drag and drop in Svelte, and we're not using any of them because the HTML API, the browser API for it, is actually really quite straightforward, at least for this use case. There's nothing massively hard that we're doing here. So I'm going to just go through those lightning quick, if I can, in just a second. But first, did want to point out that we can't run this immediately. One of the things that we found is that once you've stuck in the HTML into the iframe, you have to wait a moment for the DOM to catch up before you can do things like grab the content document or bind any event listeners to that content. So this is a function that is stolen 100% from Stack Overflow. We've all done it. And all that this does is listen to a few events on the iframe itself. So it listens for load, it listens for DOM content loaded, and it listens for ready state change. And as soon as one of those fires, it calls this, which basically just calls the init body function and stops the others, stops it happening again. That's all that does, as far as I can gather. All right, here are drag functions. I'll whirl through them. Most of what we're doing, honestly, is setting various classes on bits of content in the preview. But I'm not sure what to call this, but the drag and drop API allows you to set data on the data transfer. So when you start to drag something, you've got this data transfer object, I guess. And here we're pulling out from the data attribute the ID of the component that you're dragging for moving it, and we're saying that we're actually moving the component. This muted class stops that little drag indicator from the horizontal line from showing. I'll quickly flick back to it. We don't want that showing on the thing that you're dragging, and we don't want it showing on the one afterwards either, because neither of those two positions move it. If I let go here, it stays exactly where it is. We only really care about it if we're dragging it above or somewhere else. So we just mute. We just add a muted class to those. And finally, we're actually not quite finally, we add a drag thing to the overall container for it. I keep bashing that microphone. So that we can do the same thing for the drag container. We can detect whether we're dragging for when we're moving things down towards the bottom. The last thing here is this drag image. And that's basically this little set of squares. And the reason that we're trying to set that is that normally when you start a drag operation, the browser takes a tiny screenshot of the thing that you're dragging and sort of renders a ghosted version of that. But it'll only render the part, if it's a big thing like this that's tucked over the side, the ghost image will only be the part of it that's currently visible. So it would cut off at this point, which kind of looks terrible. And anyway, the ghosted image doesn't look great in the first place. So we set this little image as the drag image. But a little gotcha that we found is that you have to have the drag image already loaded. You can't load it when you start the drag operation because by then it's too late. And it has to already be on the page. So that drag image is always here, hidden behind this. We've just tucked it away in the corner, and then we refer to it. We've just bound that to a variable, bound that element to a variable, and then we refer to it and you set it as the drag image, and it just moves from over in the corner to where we're using it there. All right, that's drag start. When you drag something over something else, drag enter fires, and all we're doing here is if we're in the middle of a drag operation, unless you're dragging something else, if you're over a drop zone and unless it's muted, we add the over class, and the over class is the thing that basically reveals that little indicator of where you're going to drop it, that line. All that is just a couple of CSS transforms, really. And drag leave just cleans that up at the end of it. Drag over does two things. It's doing that same thing, but when you're dragging over the page as a whole rather than another component on the page. And it does, it basically, if you're dragging right to the top of the iframe or right to the bottom of the iframe, it tries to scroll it for you so that you can scroll the iframe and drag at the same time. Nearly there. Drag drop fires as soon as you let go, obviously. And here, again, we check whether or not this is a valid operation. We get the component ID from that data transfer object. And the action that you're doing, we determine whether or not you're dragging in a chip or moving something. We get the position from basically just scrolling or looping through the list of components. And if you're adding it, we compile these two functions, basically insert component, gets some, sets up some default information based on the chip that you're moving, and then splices it into the sequence in the right position. And if you're moving it, we just splice it out and then splice it back in again. So those are really simple, and I haven't put them here, so don't ask for them because I can't do that. Finally, drag end fires, and all that we do here is just clean up any of the classes that we've added so that everything is back to the state that it was in right at the beginning of the whole process. And those are your drag operations. Those are your drag events. Like I said, it's really, really straightforward. So the other thing that I wanted to just quickly talk about was some of the stuff to do with updating the preview when you're making changes to it. So that's also relatively straightforward. I think I mentioned that we try and do as much as we can through CSS variables. Obviously, not everything works through those, but stuff like setting a color just updates a CSS variable. Stuff like changing the ratio of the size of the slider and things like that. That overlay in the hero, that's done through a variable. And so each of the components, each of the little controls over in the panel on the right that updates something that is updated as a CSS variable has something like this in there, where there's a little reactive function that notices when you've updated the value of that control, and then calls this function that essentially just uses a regex to update the style property of that component in the preview, which is really quick and really simple, and means that the preview updates what looks to be in more or less real time. For something like that Quill editor, we bind the content of Quill to a variable and then find the element that represents that and just swap out its inner HTML. So that's really simple. And finally, some things can't be updated quite in real time like that. For example, when we add a new sponsor to that sponsors grid, it has to basically just run back to the API each time. So all that does is stringify just the bit of the JSON object for the page as a whole, just that individual component, sends it to the API and gets back the rendered HTML for that component specifically, and then just swaps out its outer HTML. So those kind of things, obviously that's a little bit slower, but you know, it's not slow enough that you'd actually notice for the kinds of things that you're doing with that use. All right, that's our event website builder. Got any questions? No? Oh, yes. No, that's not. Why an iframe? Basically just to, partly because the HTML that represents the page is this discrete thing that we're generating using our API, rather than done in Svelte, so that we would build it within the Svelte thing. And partly just because that sort of seemed relatively simple to isolate it. It keeps it nice and separate. It means that it's this easily scrollable thing that all that we really have to do is worry about attaching some event handlers to it.
Okay, so from your API, are you sending cookies? You just giving information?
I mean, there is a cookie that represents authenticating to the platform itself as a user, but there aren't really any. Well, okay, there are things like analytics cookies in the and obviously the little thing that comes up and says, oh, you know, do you want to accept cookies? All of that does happen in the event website, but we turn that off when you go into preview mode. So the same thing that says, okay, for each of these components, I'm going to wrap this in an extra div that's got the ID in it, also just doesn't bother outputting the bits of JavaScript that represent things like, you know, analytics cookies and whatnot.
Because we have some issues with iframe when you're using the cookies, because the tool is not going to support when you're using this external application to try to access. So I find it as a problem to change now. So.
Okay. Yeah. Well, I mean, I guess we're also in a slightly fortunate position in that a lot of what is in that iframe is under our control. So, you know, although you can set up whatever sort of analytics cookies and things that you want as a handler, because we're not injecting that into the iframe, doesn't matter what that is, because it's not going to interfere with this process in any way. Okay. Hi.
The thing that you just shown is really fundamental. Is that available? Have you published that? Just being able to drag those little gadgets around just looks like really nice.
No, I haven't published anything.
Just read the
Oh, yeah, sorry. The question was, is any of the stuff to do with being able to drag things around published in a way that people could play with? It's not, though. Sure, I'll see what I can do about trying to isolate that in a way that would be fun to do. Obviously, the product is available, but not the code as it stands.
What happens if you use it on something like an iPad or Windows touchscreen?
Right.
Does drag actually work, or do you need some kind of pointer events?
Well, it kind of works. It doesn't work great. It works more or less okay on an iPad. for it. I will admit that although we have done the platform such that it should just about work on a phone, I can't claim to have tested it as well on a phone as perhaps I should have done. But we do have a couple of additional things in there that kind of mitigate that to a great extent. So if you want to add a new component to the page, you can just basically, let's add a divider at the bottom. You can just double click and it basically just, you still have to scroll. That's just added that divider down there, so I don't have to actually drag it on if I don't want to. And equally, if I wanted to swap these two, I can control click or long press if you're on a phone, and that brings up a little tiny menu to do things like duplicate the component. And obviously we have a delete button there. So most of the operations that you would want to do using drag and drop, there is another way of doing it if necessary.
I had to tinker with something a while ago, and I wondered whether you'd solve that here, because it seems like very, very seamless and fluid the way that you did the demo, and I wondered if you could just...
Yeah, I mean, I have tried it on a phone, and the biggest problem with it on a phone is that the distance that you're moving things is actually quite far. So on a phone, we've got this preview above where all the chips are, for example, if you're trying to drag on a chip. Inevitably there, if you want to sort of drag a chip and then move your finger up to the top of the screen, it just gets a bit fiddly. So I think it sort of works. I can't think of a good way of solving the problems with it, the sort of just the UX of it, other than providing workarounds effectively. So that's what we've chosen to do.
Sorry, I'm new to Svelte, so I have no idea what this is. I'm trying to learn. This part, what you are moving the controls, is very interesting. How much is it actually Svelte?
Well, very, very little of what I've shown you is particularly Svelte specific. From what I understand of React, and bearing in mind that is next to nothing, you have to use libraries for pretty much doing most things. And Svelte doesn't seem to need that as much. So for Quill, we basically just imported Quill and it worked. For the drag and drop, almost all of that is just vanilla JavaScript. There's not really very much going on there.
700 of these things.
700 little components. That's basically because this is... I can't begin to tell you how stupid it was to embark on this project, but there we are where we are. So yeah, there's a lot of stuff in there. So obviously there's things like date components and time components and little buttons and God knows what. So there's a lot of it, and I'm not particularly looking forward to converting it. Yeah, tables and stuff. So yeah, there's not a lot that's so specific other than just that reactive function for noticing when you've updated the control. So literally just changing that changes the value, that triggers the reactive function, which triggers the update on the thing. And that's all the Svelte's really doing there.
Awesome. Thank you. That's all the time we have now for questions, unfortunately. We are going to go to a poll later. I'll just show that later. And then you can talk to the speakers personally in much more detail.
Thank you very much.